As Andrea said, February 11th. I'm just so happy I don't have to be in court today doing cases. Um, but we do it all online in New York, and it's still problematic. But we're very honored today to have some really very fine guests. Marya Ghazipura and Tanzib Houssain are two of the most knowledgeable people, not only in the United States, but especially here in New York, dealing with the whole issue of COVID-19 and the pandemic, and now the possibilities of getting the vaccines. And they bring a particularly important perspective to us from the viewpoint of New York City. And up until recently, as we know, New York City was the center of the pandemic. Not something we were very proud of, obviously, but it's now become California. So this is again something which is regrettable. We're in a situation none of us want to be in, but we're very eager to hear the latest and hear the latest recommendations and latest take on exactly what's happening and what we should and should not be doing. So without any further ado, it's my honor to present Dr. Marya Ghazipura and Dr. Tanzib Houssain. Good afternoon and welcome to you.
Thank you so much. All right, can everyone see our screen?
I certainly can, yes, thank you.
Fantastic. Well, first of all, thank you so much for having us back. It's always great to be here with Rotary. And for those of you who don't know, um, has already been mentioned, my name is Marya Ghazipura, and I'm an epidemiologist and I'm a biostatistician here in New York City. And I also work for the New York City COVID-19 Scientific Advisory Council under the mayor and the deputy mayor of Health and Human Services.
And I'm Tanzib Houssain. I'm a pulmonary and critical care physician, and much of my work over this past year has been in the COVID ICU.
And as a result, it's not a surprise that both of us have been intrinsically involved in this pandemic from the very beginning. And today, we actually want to share with you the evolution of this pandemic, both in terms of where it started, where it is, and what we expect in the future. And we want to discuss towards the end the vaccines and the variants as well. So as a bit of background, back in 2019, Tanzib and I joined a group of scientists and clinicians from across the world. We call ourselves the Task Force for Mass Critical Care. And we convened to author a textbook that was dedicated to hospital preparedness in the event of a disaster, including pandemics. And this was actually published 1 month before the first confirmed case of COVID-19. And as a result, a few months later, back in February of last year, I was invited to speak at a forum at the United Nations where I discussed the potential trajectory of this virus and how it could overwhelm hospitals and intensive care units. And within a few weeks of this talk, Tanzib actually experienced exactly what I had talked about during that day firsthand in the ICU.
Yeah, so, the first month of the pandemic was indescribable as a physician working in the ICU. Actually, if you see here, this is me full with my PPE on the opening day of our COVID ICU. This was back in March 2020 with thumbs up. I was excited for something new, not realizing the roller coaster we were about to face. So April was the peak of the first wave in the US. Some places were hit harder than others, and as was mentioned, specifically right here in New York City, the first wave really came out of our city, and our hospitals were so overwhelmed with coronavirus that most hospitals became COVID-only hospitals. We were running low on beds, so to help offload some patients, the US Navy sent one of their medical ships, which had 1,000 beds, and several field hospitals were opened up across the city, including in Central Park. But even with the additional bed space, we were short on supplies like ventilators and PPE. And most importantly, we didn't have enough staff. However, as policymakers attempted to resolve our problems, unfortunately, there was a huge disconnect between what we really needed in the hospitals and what policymakers thought we needed. So I remember when we were running out of ventilators, we were all panicking. And fortunately, after much urging, the US government released some ventilators from their national stockpile. In addition, companies around the world also mobilized to create new ventilators, and governments around the world were spending millions of dollars on trying to snatch those up. The problem was a lot of these ventilators were compact travel size versions of these larger, more full functioning ones that we typically use in the hospital. The ones that we got from the stockpile lack monitors, which we need to fine tune intricate ventilator adjustments required for complex COVID-19 patients. Additionally, they were in storage for a decade, so some malfunctioned or had drained batteries. And most of us didn't even know how to use these ventilators altogether. In fact, there was one case when we found the instructions for one of these stockpile ventilators on a VHS tape. And in 2020, in the hospital, there was no VCR anywhere for us to be able to play this VHS tape. So this impacted not just me at my hospital, but people across the country, prompting Marya and myself, along with several other experts on the task force that she had mentioned earlier, to publish a paper advocating for better ventilator stockpile policies going forward. And so as the number of cases continued to rise throughout March and April, and our hospitals remained well beyond capacity with shortages of staff, supplies, and space, we eagerly anticipated the eventual decline of this virus. And our hospitals were finally able to recover, but once social distancing measures and mask wearing recommendations began. This ushered an end to the first wave and a brief respite until the second. For most states, this was their first wave during the second wave phase. Many hospitals were unprepared in other areas to manage the COVID surge. For example, this was the case in Texas. I actually went down in the summer to work in some COVID ICUs in Texas hospitals. And the parallels to our early experience in New York was quite uncanny. One hospital was so short on ventilators that they had to obtain half a dozen types from different companies. And as you probably heard from California recently, the oxygen supply was so strained that abnormal pressure alarms were constantly going off. I don't know if you guys are going to be able to hear, but this one of the alarms going due to the high demand of oxygen within the unit. Imagine that going on nonstop in the background. And so we see the disconnect that I was mentioning in the last few slides, not only within the US, but also happening in hospitals across the globe. And what policymakers globally also had a disconnect between what was going on in hospitals and what they were offering frontline providers. So with over 16 million confirmed cases worldwide, we'll pull Egypt as an example. The lack of adequate oxygen supply to the ICU and a government that ignored warnings from frontline workers actually led to the death of every single patient in one ICU. Unsurprisingly, this degree of mortality devastated the staff. And I think that is and remains the most striking thing about this virus to us healthcare workers, the massive amount of death associated with it, especially at the beginning of the pandemic.
And we can see here what Tanzib was referring to, and that's that death rate. Unfortunately, over time, as I'm sure many of you know, the death rate actually started to decline despite the fact that there was a steady increase in the number of cases. And this is really a testament to the effectiveness of strong social distancing and mask wearing measures. You know, wearing a mask alone, even if you get the virus, now what you've done is you've lowered the viral load that you've received, making it less likely and less possible for you to end up being a severe case or even being one of the unfortunate few who die from the virus. Now, on top of better policies such as mask wearing and social distancing, we also now reached a stage where we had better treatment options at this time. We had greater access to antiviral medications like remdesivir. We also had a lot of clinical trials underway. And from some of them, we actually learned that steroids such as dexamethasone could decrease mortality. And we also started using things like monoclonal antibodies and anti-inflammatory medications such as tocilizumab. We basically learned how to better manage patients through treatments. And we also learned things from our colleagues across the globe. You know, Tanzib speaks to some other critical care physicians over in Bangladesh, and they talk about what they do in that part of the world. And small things like laying a patient prone, laying them on their stomach can actually improve oxygenation. And those are things that really this global group of clinicians have come up with to help improve treatment. And that's why mortality is decreasing. But, you know, mortality is still there. And as you can see, when the second wave hit, the number of cases across the United States drastically increased. But when we went to the third wave, it went up quite a lot. And the third wave started in October and it peaked to new heights in February, which is where we're today here in the United States. And on a global scale, what we're seeing is the development of new variants, which could explain that really high rate of cases that you just saw earlier. See, the virus has been constantly mutating over the last year. That's normal. And that's what you're seeing happen here. This is just natural selection in action. The problem is that in some cases, when there are enough mutations that persist in the virus, we get something called a new variant or a new strain of the virus. And we actually have found, and as many of you know, that some of these variants from certain parts of the world are more contagious. And the reason they're more contagious is that these variants are better able to invade our cells. Once they invade our cells, they can replicate, and that's what makes us sick. So the goal is to stop the virus from invading our cells. And in order to do that, we need to look at these spikes that surround the virus. And that's because these spikes are what enable the virus to essentially pierce through our cells and get in. And that's also why the vaccines that are currently in use across the world are all focused on getting our bodies to neutralize this protein called a spike protein on top of the spike. This is what's used to attach to our cells. So when it comes to vaccines, in the United States, we have 2 mRNA vaccines that are approved from Pfizer and Moderna. And their mechanism of action is actually quite simple, contrary to some of the fears that people tend to have. See, they rely on a small piece of messenger RNA, so mRNA, which delivers a code for our bodies to produce the virus's spike protein. So scientists take that code and they wrap it up in something called a lipid nanoparticle. And the best way to explain this is think of it as putting a set of instructions into an envelope. That's all it is. That's what's being injected, a set of instructions in an envelope. Our body then reads those instructions and produces the spike protein. And remember, it's just the spike protein, not the virus. So the spike can't harm us because the rest of the virus is not attached to it. Instead, what's happening is that the presence of the spike protein in our body signals to the body that there is a foreign particle. And so our body gets this immune response, triggering the production of neutralizing antibodies against the spike protein. So now, if you ever do get exposed to the virus, someone coughs on you, someone sneezes on you, the virus will be in you. But you have this huge store of neutralizing antibodies against this spike protein. So the virus can't enter your cells, meaning you won't get sick. Now, of course, there are other types of vaccines out there as well. For example, AstraZeneca and Johnson & Johnson are some viral vector-based vaccines. And these are somewhat similar. What these vaccines do is they take the gene that codes for the spike protein and they attach it to an adenovirus. And an adenovirus is this harmless virus that's basically similar to a cold. And the adenovirus is really used more as a truck to transport that gene that codes for the spike protein into your body. So that's what gets injected. Your body recognizes it. And again, your body just produces the spike protein, not even the spike. And once it produces that spike protein, you generate an immune response. And again, you form neutralizing antibodies against that spike protein. And finally, the last kind of vaccines we have are the classic vaccines. Novavax is one of the examples, and they're protein-based vaccines. You might be familiar with them. Most vaccines that we probably received in our past are protein-based vaccines. And this is when they directly inject you with the purified spike protein. All you have is the spike protein. Again, you don't have the virus. And that triggers our body to produce antibodies against the spike protein. And we get that immune response. And again, we have that store of antibodies in our system, and that protects us in the future. Now, I'm sure you want to know how these vaccines compare to each other. Well, like I said, 2 of them are mRNA vaccines. AstraZeneca, Johnson & Johnson, they're viral vector vaccines. Novavax is a protein vaccine. And with the exception of Johnson & Johnson, they all require 2 doses. So you need a booster dose for each vaccine except for Johnson & Johnson. Now, when it comes to protection from mild disease, the mRNA vaccines from Pfizer and Moderna are the most effective. But mild disease isn't really why the pandemic is a concern. If you have mild disease, you're likely going to recover and at some point get better, and you don't need to end up in the hospital, and you shouldn't have trouble breathing or anything like that. So what we really are interested in is how to avoid severe disease. And all of these major vaccines that I just mentioned, apart from Johnson & Johnson, offer 100% protection against severe disease. And on top of that, and this is what's most important, every one of these vaccines offers 100% protection against death or hospitalization if you're exposed to the virus. And that's why vaccine dissemination is so important. We've seen the rates, we've seen how many people are dying from COVID-19, but regardless of which vaccine you get, sure, you might get mild disease with some of these vaccines, but the probability of you dying if you're vaccinated is slim to none. But of course, there are some hurdles in vaccine dissemination. For example, the mRNA vaccines are not only the most expensive, but they're also the most difficult to store. They require incredibly cold temperatures, and so it's less of an ideal option for low resource settings. And so now I'm sure another question you might have is, which vaccine should I take? The short answer is whichever one you have access to. Well, the mRNA vaccines offer a slightly better protection against mild disease, as we discussed earlier. Again, every single one of these vaccines that we just discussed offers 100% protection against death or hospitalization if you get infected. And most of these vaccines also have great protection against severe disease as well. But naturally, a lot of you may have concerns, so let's squash some of them. One of the first concerns that people bring up is if these mRNA vaccines were rushed. No, they weren't. In fact, this technology for mRNA vaccines has been around for almost 30 years. They were studying it when they were trying to develop the Ebola vaccine most recently, but it's just never been used in a mass vaccination campaign. They tend to be a little bit expensive, and quite frankly, we haven't had a need to create a mass vaccine campaign using an mRNA vaccine up until now. And on top of that, one of the benefits of an mRNA vaccine is it's actually just created in test tubes. So a lot of other vaccines, you have to grow or cultivate living cells, which can be very time consuming. So that's why the mRNA vaccine was able to be produced so quickly. We already had the research, and it was quick to produce because of the nature of the technology. Another question, can the mRNA vaccine alter our DNA? No, it can't. And it's a great question because we hear mRNA, we know RNA is related to DNA, but our DNA is actually wrapped up inside a double membrane nucleus. And it's pretty much impossible for the mRNA to get inside. And also the area that the mRNA tackles is really far away from where your DNA is anyways. They're just not going to cross paths. It's pretty much impossible to happen. Not to mention, our body breaks down mRNA very quickly, as early as in 72 hours. And that's why we absolutely need a second booster shot, because the mRNA is not enough. Our body breaks it down as soon as possible, so we need that second shot. So it won't persist in your body, and it's very safe. And another question is, can the vaccines give you COVID-19? Well, I hope from the diagram I showed you earlier, you can kind of understand that mRNA is just a messenger. The mRNA is delivering a gene that codes for the spike protein. That's all it is. It's a set of instructions coding for just the spike protein. It doesn't code for any other part of the virus, not even the spike itself. There's no virus attached to it, so you can't get the virus. You just have a little bit of a code for a protein in there. Your body creates that protein and then gets rid of it right away. And people wonder, for those who have allergies, there is no egg or dairy products inside the vaccines. And finally, the side effects. They want to know what the side effects are. Well, there are side effects, but they're minimal. Tanzib and I both got vaccinated. We had both of our doses. And both of us experienced flu-like symptoms for about 2 days. For some people, the flu-like symptoms can be quite cumbersome and quite annoying. But one thing that seems to be a common thread is your arm gets quite sore after the vaccine for about 2 days. But that's completely normal. When you experience these flu-like symptoms, when you get that fever, that's your body generating that immune response. That's your body generating those antibodies. And that's a good thing. And rest assured, in 2 days, that's going to be absolutely gone. It's like nothing ever happened. And it might happen again in your second booster shot. And then again, it's like nothing ever happened. You basically have a couple days where you experience flu-like symptoms, but it's much better than experiencing the onslaught of disease that COVID-19 can bring. And I know some of you are simply just not ready to get vaccinated, or it's not your turn yet and you're not in line to get the vaccine just yet. And that's okay. At this point, it's just so important to take every single precautionary measure to prevent yourself from getting sick. And that includes wearing your mask and social distancing as much as possible. And if you are vaccinated, the unfortunate reality is we must still wear our masks when we're in public. What the vaccines do is they prevent us from getting sick if we get exposed to the virus. But you can still have the virus inside you. And that means that you can still transmit the virus to other people. You just won't get sick from it. And there's a big difference. So when you're around unvaccinated people, you do need to wear your mask. And with time, new variants of the virus will continue to emerge. As of now, we know that most vaccines, particularly the mRNA vaccines, offer at least some protection against most of the new variants. Unfortunately, we don't know the exact degree of protection. Some studies have come out and reported certain percentages and certain numbers, but I would take them with a grain of salt. The reality is that these variants were not this prevalent during clinical trials. So the sample size and the number of people that they had with these strains and with these variants were very low. So we can't make conclusive judgments on it just yet. But rest assured that data is underway. But the virus will continue to mutate. And as it continues to mutate, we're going to keep getting new variants. And at some point, we may get a variant that the current vaccines don't protect against at all. And maybe even a new variant that's more lethal and not just more contagious. So until then, luckily, pharmaceutical companies across the world are working on new vaccine formulas, just in case there's a potential of a new variant in the future that can do this. And yeah, that might mean we have to get vaccinated again and again, similar to a flu shot. We don't know yet. We don't exactly know what the future has in store, but what we do know is that all of this is a possibility. A good way to avoid it and a good way to kind of see the light at the end of the tunnel is to really mobilize ourselves as a global community and realize that there is such an urgent need to reach herd immunity as soon as possible. And vaccines can help us get there. It's really just a race of us against the pandemic. So thank you so much for your time. And I know there will be a lot of questions and we're so happy to answer any questions you may have.
Andreas, do you want to field the questions?
I'm sorry, I was on mute. Absolutely, we can do it, and we can do it jointly, President Gerard. But we do have a question right now from our dear Irish friend and Rotarian, Frank Bannister. Frank, you can just post a question if you so care.
Yes, I'm curious to know why the Johnson & Johnson vaccine only requires one dose when all of the others seem to need two.
Yeah, so actually that was what they were studying in the first place. They wanted to know if it was possible to create a single dose vaccine, and they also wanted something that's a bit more feasible. So one of the things with the vaccine is vaccine dissemination programs in some parts of the world are quite feasible. In the United States, it's not too difficult to get people to come in for 2 doses, but when you're looking at certain parts of the world, especially low resource settings, getting the same people back for a second shot is not necessarily feasible. So different companies started working on different formulas to ensure that every single person can have some sort of protection and some sort of coverage. So something like the Johnson & Johnson one, the initial study design was trying to figure out if we can have a vaccine that is effective against disease, against at least death and severe disease with only 1 dose. And that's an absolutely wonderful alternative in those sorts of settings. So the gist of the story is that they designed it so that it's only in 1 dose, but that's also why it comes with some limitations. It isn't as effective against mild disease, and it's also not perfectly effective against severe disease, but the goal was to have something that's completely effective against mortality, and they got there.
Several viewers asked basically the same question. Do you think it's going to be required that we have these vaccines on a yearly basis, especially with the mutations?
Yeah, it's quite possible they'll be similar to the flu shot. So the reason we get a new flu shot every year is that it mutates and there's a new variant every single year, and we have a different kind of flu every year. And we're used to that. Society is able to move on smoothly with no problem. Before COVID, we didn't have to wear masks. We were able to move on with our lives. So yeah, it's always a possibility we'll reach a point where the virus will continue to mutate so much that we'll need a new vaccine. Now, right now, we do believe that the mRNA vaccines offer some protection against the new variants. And the reason is that these new variants, they emerged and became more contagious because of mutations specifically on the spike protein. So what happened is the spike protein has mutated to be able to pierce our cells even more easily. So these mutations have made it easier for the virus to enter our cells. And once it enters our cells, it's easier for us to get sick. So the nice thing about the mRNA vaccines is that the code that the mRNA delivers, it codes for the entire spike protein as opposed to just part of it. So as of now, every single part of the spike protein is covered. And as of now, every single variant, there's at least some protection against it. So look at it this way. Right now, we know that Pfizer, for example, is 95% effective against mild disease. Against the variants, it'll still be protective, but we don't know the exact number. It could be 60%. Some reports have said around 82%. Other reports have said that's inconclusive. The point is there's still some protection, but not enough. And eventually the virus might continue to mutate and these vaccines won't provide us with enough protection. And the worst part is if the new variant becomes the dominant variant. And if the new variant becomes the dominant variant, then it's not about just the small possibility of this small variant. Then it's just, there's a whole new variant out there that this vaccine doesn't cover, and we'll need a new vaccine every year. So it's certainly a possibility. It's certainly in the works, but the goal is to get us all to a stage where we have enough immunity amongst us that we might still need a shot every single year, similar to a flu shot, but we don't necessarily need to mobilize an entire population to do so.
Yeah, and I anticipate the Johnson & Johnson being one shot is likely going to be the most dominant one over time. Right now, the mRNA vaccines they're the fastest. They're the first ones out. So they're the ones that get most of the attention. But when you look in a global scale, because of the ability to actually get to transport the actual vaccines across, and due to the manageable nature of the supply chain with one dose and lower temperatures for freezing, I think, or more manageable temperatures for freezing, I think the Johnson & Johnson might actually overtake everything else in the long run.
Mhm.
But the benefit of the mRNA vaccines for these variants is that it's quicker to produce. So if there are variants that are escaping what we currently have, it'll be faster to be able to produce a new vaccine to be able to distribute. But then once again, who gets that vaccine? Most likely countries that can afford it versus those who can't.
Mhm.
And so those are a lot of things in terms of vaccine distribution that need to be weighed and considered in terms of equity of availability.
Yeah. So, and the last point to mention is that these Johnson & Johnson vaccines, I know some of the numbers might make you think that the mRNA vaccines are the best. Well, it's important to remember that the Johnson & Johnson vaccines with only one dose, a significantly lower cost, much easier storage, not only in terms of the temperature, but you just can put it in the refrigerator. But if you put it at negative 20 degrees Celsius, it can actually store for up to 3 years. So, and it's 100% effective against death. So, and hospitalization. So, yeah, you might still get mild disease. Yeah, you might still get severe disease too. It's 85% effective against severe disease, but you can still get severe disease. But it's 100% effective against a disease that's so severe that requires a hospitalization or that will result in death. So, as Tanzib was saying, that's probably why Johnson & Johnson might prevail more on a global scale, simply because of the feasibility of implementation. And the most concerning outcomes are, of course, being hospitalized and dying. And that's really what most people are trying to prevent.
Thanks so much. We have a question from former New York Rotarian now residing in Switzerland, Thierry Poignant. Thierry?
Yes, a question. Thank you, Andreas. A question concerning the curative drugs, because we talked about preventive drugs with vaccines. There was a paper published in France a few days ago about the use of drugs initially designed for major depressive disorders like Prozac. And apparently using these drugs could prevent the cases of severe COVID-19. Did you hear about that?
So actually, I haven't heard about that specifically, but actually I'm very curious to look that up now. But what I can say is that there have been, throughout the last several months, multiple different medications that have popped up as potentially curative or very significantly improving mortality or side effects from COVID. But they often show promise in initial smaller studies. But then when randomized controlled trials are done on a larger scale, we tend to see that effect lost. And so
which one would be the most effective for you today? If you had to mention, to give the name of the most effective curative drug against COVID-19 today, which one would it be?
So I think there isn't anything as of today that's curative. All the medications we have as of right now they basically treat symptoms and side effects of having the virus. And they may shorten the time in the hospital, shorten the severity of the disease. The key ones as of right now that we're using, I think the one that is hands down found to be effective in lowering mortality, as Marya has mentioned, is our steroids. So initially, what we had seen with patients with COVID-19, you have the viral phase where you're infected with the virus. So you have the viral prodromes, you have the respiratory illnesses, you have the body aches, sometimes GI side effects, or some people even had side effects with their smell and taste. But that was all from the initial viral prodrome. Subsequent to the virus, you had the body's reaction to the virus, which led to a heightened immune system and a heightened immune response, which then didn't just attack the virus, but attacked the rest of the body. So what we've found is that dexamethasone specifically, but steroids in general, are effective in decreasing that second component where the heightened immune system attacks not just the virus, but the body itself, leading to multi-organ failure. So we've been able to prolong survival essentially in patients with COVID-19 and keep milder cases from becoming more severe by giving steroids the moment someone needs supplemental oxygen. So that's the recommendation right now for steroids. As soon as someone needs oxygen, you start them on steroids. And the hope is that that prevents that secondary cascade of the heightened immune system leading to multi-organ failure. So that we have seen in randomized controlled trials to be effective. Additionally, monoclonal antibodies have been shown to be effective, as well as like tocilizumab, which are anti-inflammatory medications, but more in the mild phase before patients get into the ICU. So in the mild to moderate phase, before hospitalization, some of these medications that earlier Marya mentioned are what we are using in the hospitals. But getting access to monoclonal antibodies is not easy. It's not available everywhere. And the price of medications like tocilizumab, which are IL-6 inhibitors, which are basically anti-inflammatory medications that block the cascade of inflammation, are also very expensive, so not very easy to get. Whereas steroids, dexamethasone, is very cheap and easily produced and found all over. So I think those are the key medications used as of right now. And additionally, one other in-hospital medication are anticoagulants. So a lot of patients with COVID end up having microthrombi, so clots throughout the body in different areas that also lead to the organ failure. So a lot of patients have been given anticoagulation while they're in the hospital, blood thinners essentially, to make sure that those clotting events don't occur. Although newest data has shown that once someone's in the ICU setting, severe enough to be in the ICU, then the risk benefit of the anticoagulation actually isn't great, and the bleeding risks are higher than the benefit you get from it. So a lot of medications are in the works, seem to be helpful in earlier phases when things aren't as severe. But once you get to a severe stage, unfortunately, there hasn't been anything of great value that can stop the progression of the disease at that point. But the challenge is who has access to those medications aside from steroids.
Tommy, do you want to ask me a question about age?
Sure. I have a new microphone, so let me know if it's not coming in good. Can you hear me?
Yes.
Great. So I was wondering if there's a minimum age that you guys would recommend the vaccine for, because children obviously haven't been able to go to school, and where can we expect children, at what age would you feel safe giving it to your child?
Well, right now, unfortunately, we won't be giving it to children. The clinical trials are currently underway in children, but for most drugs, including vaccines, they tested on adults first. So right now, it's been approved in the United States for ages 18 and up. Some vaccines have been approved for ages 16 and up, but as in terms of a pediatric cohort, that's being studied now. So once it got approved for adults, now they're studying it in children. And that's what kind of makes some of the policies for children returning to school a little challenging, because mass vaccinations in schools can't happen. So what they're doing is vaccinating educators and vaccinating teachers as much as possible. And if parents are vaccinated, then we can kind of be in a better stage, because younger people, especially children, if they do get the virus, they're less likely to have a very severe reaction to the virus. It's when they start passing it on and transmitting the virus to older family members and to the community as a whole. So what they've currently done is start vaccinating educators, parents, but children hopefully soon.
Thank you so much. And while I have you, I figured I'd just thank you guys so much for this. And one other thing that there's a lot of rumors going around, and I don't think I saw anyone put the question in there. And you guys seem like such a fantastic resource. So while we have you, there's a lot of rumors that are going around about and unmerited, you read them and you have no idea if they're true or not, but sterility, for, adults. And it's way too soon to know if that's the case, but I know, people of those, years, childbearing, they're worried about that for both men and female. So figured while we have you, might as well get your thoughts on it.
Yeah, actually, it was funny. I mentioned this to Tanzib that this was just when they were first talking about the mRNA vaccine. I said, I guarantee you people are going to be wondering if this is safe for women who want to have kids, because a lot of drugs, reality is a lot of things can impact fertility a lot. The benefit is this doesn't. The short answer is that of course, in theory, you don't really know anything until we look at things years down the line. But there's absolutely no biological plausibility. In the same way, people wonder, well, how do you know it doesn't change our DNA? Don't we have to wait 20 years and see what happens to our DNA? Well, we just know it's just clinically impossible. Your DNA is in this tightly wound membrane with 2 layers. The mRNA hits the ribosome, which is way over here. They'll never interact. And then in 72 hours, the mRNA is gone. Likewise, the mechanism of action for these vaccines, the area at which it attacks, there's absolutely no possibility it can attack anything that will impact our fertility. And it's simply just due to the mechanism of action. So I understand when people say, I want to wait it out. I want to wait to see what happens to the general population. I want to wait a couple of years. I understand that, but for certain outcomes, I absolutely agree with that. But there are other outcomes when we can see no biological plausibility of it happening, then there's no point in waiting because it can't happen. It's different if it's a maybe. Well, maybe it'll happen in 20 years and we'll find out. But fortunately for us women, that is not something we need to be concerned about. And it's safe to take if you're pregnant or breastfeeding as well.
I know some mothers who have gotten it that are pregnant. So thank you for answering that. I know a lot of people in my network have been asking me that question. I'm like, I don't know. I'm not a doctor. I have no idea. But thank you for coming and sharing that with us. I really appreciate it. And thank you for a fantastic presentation.
Oh, well, thank you.
Thank you. We have another question. It ties in with something also that I've read about a study in Israel that seems to favor a drug called EXO CD24. It's a cancer drug. But without answering my question, I'll give the privilege to our speaker next week, which ties in with my question as well. And Miklos, would you like to ask the question? Miklos Gornagi is the Hungarian trade attaché.
Yes, thank you very much for the possibility to ask, and thank you for this great presentation. It was wonderful, especially because Hungary, we are having some problems with the supply.
Can you speak a little louder, Miklos?
Oh, can you hear me now?
Yeah, much better.
Yeah, it's better. Yeah. So thank you for the presentation. It was very interesting. Since in Hungary we have some problems with the supply of the vaccines, so we are having very good connections with the Russians and with the Chinese as well to give us as much as is possible. But as I can see, it's very good to see that these are already proved that these other vaccines are also great and trustworthy. My question is the following: that what do you think an appropriate treatment in the future which prevents the disease can replace the vaccination at all, so that will be safe? Okay, we can have this treatment and there is no need for vaccination in the future.
Well, that's kind of the goal. I mean, so far there's a lot of drugs. Everyone wants to know about the drugs. There's that drug that the cancer drug you were talking about, that's in early trials, and you'll always see the media coming out and saying this drug can cure it, this drug can cure it. Reality is not a single drug out there can cure it, not right now. We have early data, for example, the cancer drug, we have early data on 30 patients, but 30 patients is not enough to decide if something can cure anything. So far nothing can cure it, but we have treatments that can maybe improve your chances. An ideal situation, of course, is to have a drug that can cure it. But what's very complicated and why it's so difficult to come out with this drug is when you get infected and if you manifest it as a disease, what happens is that for some people who manifest it as a severe disease, it has a systemic inflammatory reaction to your body. it's not just impacting your lungs. People see it as a respiratory disease. It impacts your heart. It impacts your kidneys. It causes blood clotting. And so, I remember reading a lot of reports where people were saying that the death rate is exaggerated. And all these people, they're dying from blood clots and they're dying from heart attacks and they're dying from this. They had COVID and that's why they got the blood clot. They had COVID and that's why they died from kidney failure. So yes, they died from kidney failure, but they got kidney failure because they had COVID. So that's what complicates it is everyone's dying. Their endpoint is something different. So what we need to do is stop this systemic reaction altogether. But it's very challenging to have a drug that targets every single organ and every single part of the body because again, some people will die from kidney failure and some people will die from blood clots. And it's this systemic nature of the virus that makes treatment so challenging. And that's why, as Tanzib was saying, sometimes we give this treatment and sometimes we give others. What you need to do is evaluate how the patient is manifesting disease and what's really going on. In some cases, you can try different monoclonal antibodies, but in some cases, it might be better to just stick to steroids because there is no real answer. And so it's a very challenging question to ask too, is what would be an ideal drug? And I don't know if there will ever be one ideal drug. I think what's going to happen will be there might be multiple drugs to assess different issues. There might be an ideal drug for people with mild disease and an ideal drug for moderate disease. But when we're looking at people who are so severe that they're hospitalized, now they're at a point where they're getting blood clots and other parts of their body are shutting down. Then we might need drugs that address those specific parts and those specific organs and address inflammatory reactions in those areas. So it might be a multi-pronged approach as opposed to just that one perfect pill, which would be great. But people are working on it. There is quite a large possibility that they'll come out with something that'll be really great for those with mild to moderate disease. And if we're able to take it early enough, it can prevent us from getting worse and getting into severe disease. So that'll be a great first step. But of course, the goal is to stop people from getting to that point, from needing to be hospitalized and from dying. So I know that's not the answer you were looking for to say that it's a multi-pronged approach, but I hope it helps you understand why there hasn't been anything that is completely curative just yet.
Barbara,
Thank you very much.
Barbara, you had a question about blood types. You're on the phone somewhere? Barbara? I guess not. Andreas, do you have someone else there?
Yes, we do. Actually, before we go to Helen, I want to give Scarlett Pildes the privilege of a question since she also originally introduced these wonderful doctors to us. Scarlett, go ahead.
Oh my gosh, I have so many questions. So great to see you. Thank you so much. It was my cousin that asked the question about Rh negative. I don't know which question I wanted to ask first. Oh, do you have any comments on ivermectin, whatever that is?
Yeah, so actually, ivermectin is a anti-parasitic drug essentially, and it's actually a very cheap drug, commonly used all over the world, especially in developing settings where parasitic infections are higher. But ivermectin, I know, as Marya was mentioning, I communicated with a lot of doctors in Bangladesh, and there are many case studies in Bangladesh where physicians would mention that, hey, we've been giving ivermectin to our patients and have seen a significant response. And so this was studied actually on a larger scale in multiple different areas. And based on case studies, ivermectin has shown some promise. But I think the last group of larger studies I saw didn't really point toward a clear benefit. And as of right now, the recommendation is there isn't any strong recommendation to use ivermectin for patients with COVID-19. Obviously, if studies continue and something is shown that's significant, that might change. But from my understanding, as of right now, the current studies don't point toward using it regularly. And it's possible some patients benefited. Obviously, the individual stories that have been mentioned, especially in Bangladesh, where ivermectin is used for parasitic reasons, the physicians there were very adamant, like, oh, this actually worked. So it's hard to tell, is it the medication that worked, or were those patients going to do better anyway? Were there a different group of patients that, regardless of the medication you gave them, would have improved? So that's where we're not quite sure. There was some initial promise, but larger studies still are in progress to get a definitive answer.
Thank you so much. Can you comment briefly on the blood type question, because my cousin asked it?
Of course, and actually there was a article in the Annals of Medicine in January that documented, they took, I think, like 300,000 patients and saw that Rh negative and O blood types, so and specifically, so if you're O negative, have a protective feature. They are less likely to develop ARDS, which is acute respiratory distress syndrome from COVID-19. So there are data suggesting that, yeah, there is some protective benefit with blood type.
Thank you.
Helen, would you like to pose your question?
Yes, I came in a little late, so I don't know whether this question was asked. Do they know yet how long you're immune after taking the second shot?
That's a great question. And no, I really wish we did. The unfortunate reality is we don't know how long exactly we have immunity, because the virus keeps mutating. Because the virus keeps mutating, suddenly the effectiveness of these vaccines that I stated earlier, for example, all of them are 100% effective at preventing mortality, but, for mild to moderate disease, they vary in their effectiveness. Well, the numbers that we have reported are for the dominant variant in the region that it was being studied. So as new variants are emerging, those numbers are likely to change. So we don't know how long it's protective. People have hypothesized that, assuming a perfect world where the virus is not mutating and there aren't new variants emerging, then they anticipate there'll be about a year of efficacy similar to a flu shot. And they've basically hypothesized that based on patients who've acquired severe disease, looking at their antibody titers. And they found that on average at about 10 months is when their titers start dropping precipitously, meaning you don't have as many antibodies inside you. That's not a bad thing. It just means you just don't have them anymore. And similar to a flu shot, you might need another one. With that said, we don't know for sure. This is also new, that we don't know how long our antibodies are going to stay in our system. And also the duration of immunity might be different by vaccine as well. And no vaccine has reported what that duration is. We can only hypothesize.
And what about type A blood? I don't know if you mentioned that. My daughter has type A. Is there one vaccine that's better than the others for that type of blood?
So the vaccines actually are all the same for blood type. It's more that your blood type, they're finding that there's an association that those with O negative blood type are most susceptible to getting sick, or not most susceptible, or most least susceptible at getting sick. And those would be positive are the most susceptible at getting sick. So the vaccines themselves don't change your immune response. So luckily they're homogeneous across blood types.
Okay, thank you.
Marya, I wonder if I may pick up on something you said a few moments ago. And my question relates to testing and what would be the best kind of testing to get. You mentioned that originally COVID was viewed as a respiratory disease. And in fact, last March, when I contracted it, I was tested 3 times, the swab test, 3 times within less than a week in 2 different hospitals, came back negative. And that night I wound up in the intensive care because they did a blood test and found that I was loaded with it. So my question is, short of having a blood test, which is not practical for tens of millions of people, is there a better test for the average person to take than a swab test?
Unfortunately, the best test right now is a PCR test. Now, perhaps one of the reasons that we don't, at least towards the beginning of the pandemic, there wasn't a standardized method on how to do it. So people weren't necessarily trained on exactly how deep to go. And sometimes they don't go in as deep as other times, depending on how frequently you need to get swabs. I know, for example, in New York City, my friends who are educators, they say that they don't go all the way inside because they have to do so many people and they have to get repeat tests. So for the sake of comfort, they don't go in so deep. And what that does is it reduces the accuracy of the PCR test. The best test you can get is a PCR test. And now, at least, the methods of doing the swab have improved. For example, every time I've gotten a swab, they sit there and they count for 11 seconds, and it's 11 very uncomfortable seconds. But I remember earlier in the pandemic, no one counted. They just put it in and they took it out. And sometimes it could be there for 11, but sometimes it could be there for 2 because we didn't have any standardized approach. And without having a standardized approach, we were getting a lot of false positives and false negatives, and leading to situations like what you unfortunately had to endure. So what I can say is that the method that were being used back then, it's still the same, but it's been improved. So there's always going to be a risk of some false positives and false negatives, but at least we know that the risk has gone down because we have a more standardized approach.
Yeah, and also at the beginning, there were a lot of different companies, a lot of different ways to test. And so there was a variety of accuracy on each of those available tests, depending on what tests was done at your location, what they had access to. There could have been a lot of variability, whereas now I think places have kind of standardized the approach.
Yeah, they're much more sensitive now, the technology at detecting the presence of the virus. And of course, it's not perfect, but it's much more accurate than it was, provided that the swab was done correctly. And and at least in the United States, I can say for most hospitals in New York, they have much better PCR testing.
Thank you. Andreas?
Yes, we can probably still fit one more question in, and I give that privilege to Tyler Bauer. Tyler, how you doing?
Yes. I just had a question in terms of how, I think general health has been a topic in the US for a number of years. And just how, with new variants coming up and different, kind of an endless possibility of them, not to be too negative, how does general health and just improving the general health of the population help us be more resistant to pandemics in general? And how does that factor? I know you advise the mayor on like disease, but how does that kind of collaborate with nutrition and other areas?
Yeah, that's a really great question. General health obviously is very preventative. Having optimal health is very preventative at getting severe disease and dying. There's a reason why the majority of people who are in that position have comorbidities. And another very unfortunate reality is it's not just general health. There's so much more to it. You might see someone who otherwise looks very healthy, but they may end up in the hospital, may end up in the ICU. And we see that there's a much higher risk in low income African American, Latinx communities, at least here in the United States. And it goes way deeper than poor health, because these are people who look like they're otherwise healthy. What's happened is that they're in an environment, and that's through a systemic issue of poor access to healthcare, low access to healthy, nutritious foods, where they could look on the outside like they're healthy and they could have no other pre-existing conditions, but simply due to the nature that they haven't had preventative healthcare, simply due to the fact that they don't eat healthy foods on a regular basis, they don't have access to great groceries, they don't have access to affordable housing, they have different stress levels. The nature of their jobs often require a lot more exposure because some of them are working at the front lines and they're living in these multi-generational homes. So they're around people who are, a lot of people, it's hard for them to quarantine, and they're constantly being exposed to one another, and their housing conditions might not be ideal. So in addition to focusing on our general health, I think it's one of the first times that a disease has forced us to evaluate our relationship with other people in a way that maybe we never wanted to look at it. And before you see that in so many parts of the world, and unfortunately a lot in the United States, the health of low-income communities goes ignored. Look at Flint, Michigan, and look at that water situation. It goes ignored because it doesn't impact the wealthy. This is the one time where the entire population is affected by every single community, because those people in those communities, they work in our communities too. And so we finally see the interrelatedness and how everything's kind of coming together. So honestly, one of the first things we need to do is improve population health, the health of the entire population. And by that, I mean improving access to preventative health care for all communities and nutritious foods. But also, optimizing your health. We can get into taking certain supplements. Vitamin D has been associated with, low vitamin D levels have been associated with higher risk of disease. So replenish on your vitamin D, your vitamin C, your vitamin B12, your zinc. Living a healthier lifestyle can help prevent it all too. But at the end of the day, regardless of how healthy you are, you can still get sick if someone around you is sick. So the best thing to do is keep your entire community in an optimal situation and not just ourselves. And I think it's definitely one of the few times we were forced to see it that way, even if we didn't want to. And I know that doesn't directly answer your question, but I just think it's, for individual health in this situation, population health is so important.
Thank you. Andreas, I think.
Yeah, President Gerard, I think you wanted to still make some remarks in the presentation since we're at the end of the time, right?
Yes, thank you. Thank everyone for being here. Marya, Tanzib, really at a time when rumor and misinformation is everywhere, you have really done us a great public service by letting us know exactly what the facts are. We're all upset, of course, but having the facts is reassuring and enables us to make the right decisions. And we thank you, really. As you know, Rotary Club is the largest charitable organization of its kind in the world. They're literally in every country in the world with very few exceptions. And what we want to do today is to thank you so much for what you have contributed to Rotary and to the people, especially of the city of New York. We would like today to make both of you honorary members of Rotary Club of New York, which gives you access to every Rotary Club in the world. And thank you. So Andreas will get all of the information and paperwork to you. And we want to thank you so much for being with us. It's always an honor to have you. You're invaluable to us. And we all realize how our medical professionals really are above and beyond probably the most valuable people we have. And we cannot thank you enough for the work that you do and the help that you provide for all of us around the world. Thank you so much.
Thank you. It's such an honor.
Our pleasure and honor to have you with us today. Okay, thank you. I want to remind everyone next week that Miklos Gornadji will be our guest at our UN breakfast. We're going to have our youth empowerment session the end of this month. And for those of you who don't know, the Police Commissioner, City of New York, has chosen Rotary Club of New York to be the intermediary between the New York City Police Department and the various communities in the city of New York. And so beginning in March, we will have a number of well-known guests who will participate in what we plan to be the first community-based meeting to try to bridge the gap between police and our communities to bring about better understanding and communications between both groups. So we invite you to participate and please have your friends and relatives join with us. Andreas, he does such a great job for us. He'll get all the information about the how to log on to the links. And we hope it'll be the beginning of something that will continue for many years with Rotary clubs, not only in New York, but we're talking about with Rotary clubs in other communities doing the same, acting as a mediary between our government and the needs of our communities. Again, Marya, Tanzib, thank you so much for what you have given to us today. We love you both. And welcome to Rotary Club of New York. And everyone else, thank you. Stay safe and stay healthy. Thank you, Andreas.
Thank you.